All right, hello everyone. My name is Larry Touchette. I'm from Pure Storage. I'm a director of product management on a team that's building a new product that's coming up soon from us that we call Pure Fusion. You may have heard about it a little bit on the internet. We've launched it back in September. So we're pretty excited about working on this. As Steve mentioned, Pure's been around for quite a while. I've been at Pure myself for almost 7 years now. I think this September is going to be, might be my 8th year. So I've worked on lots of different technologies at Pure, all the way from our original flash array to some of our cloud side stuff to the way we do upgrades and that sort of thing. This is something new that's coming up. I do got a bit of a legal disclaimer here. So basically everything I say in this presentation is forward-looking because we have not GA'd this product yet. So it's coming soon from Pure. Our goal is to ship it before the end of the first half of this year. But I feel pretty comfortable saying it's coming soon. A lot of folks at Pure are working on it pretty hard, and we're pretty close to getting it out. We're going to talk about a lot of what Fusion is going to do, as well as a lot of what our vision is for Fusion and what we expect to do with it in the future. I'm going to start by talking about why we're making this product and what we intend to do with it. And then you only get to listen to me for a short amount of time. And then Anthony will come up and talk to you more in depth about how the product works. And we've even got a couple demos planned to show you all. So one of the things we've noticed that's been going on for years now is that as more people start to consume and utilize services in the public cloud, it really creates this sort of on-demand culture where everyone who's using public cloud gets used to getting resources on demand. And companies want to provide that similar sort of experience both in their private clouds as well as what they get when they utilize public cloud. And every company today, especially every big enterprise, is having to mix some of both. Like every company has some on-prem infrastructure, some on-prem applications, traditional applications, cloud applications. Some companies are running traditional apps in cloud. Some companies are running new container-based apps in cloud, new stack stuff in cloud, and even doing some of that on-prem. So the main things are here. I'm not going to read every bullet on this slide for you guys, but the key things that we're interested in is agility. I mean, that's what people get by going to public cloud. Getting things like data services like protection, snapshots, replication, that sort of thing are all things you can just easily apply to the storage that you're provisioning without having to do a bunch of backend configuration to get that kind of thing. Another very key thing that we're delivering with Fusion is the fact that once users get into a Fusion environment, they don't need to have any interest in the underlying backend infrastructure. So it's very, very cloud-like. You want a volume to store data in, you want a file system to store data in, something like that. That's all you want. You don't care about the network switch. You don't care about the storage appliance on the backend. You just want to get access to the services that you want. Now, traditionally, when you look at the way storage has been managed, it tends to be, things tend to be very siloed. The storage appliances themselves get managed very localized. And not only are we trying to solve this sort of front side facing problem for consumers trying to get access to storage so that they can store data, but we're also with Fusion solving some backend issues for teams that have to administer and manage storage systems on the back end. So when you're using public cloud services, you get very uninterrupted access to your systems. Like I said, you don't care about whether there's a backend storage array there. You don't care whether or not there's a network between the compute that you're using and the storage you're using. You just want access to your storage and you want it to be available all the time. On the back end, someone has to provide that service to you. Whoever's managing that infrastructure on the back end, they need to have certain tools available to them to allow them to lifecycle that environment and manage the environment and potentially even change the backend environment, ideally without you as a user ever even knowing that they're doing those sort of things. So Fusion is not about simply bringing a cloud-like sort of model to how you provision and use storage, although that's one of the major things it does. The other very important thing it does is provide people with a mechanism to run the environment as a cloud-like service provider on the back end, and do that with some storage in the cloud or do it with storage on-prem. A couple specific things we looked at when you look at the way traditional storage gets managed is there are several different types of clustering technology when it comes to storage. There are HA pairs. Some storage vendors have an HA pair type solution. Others have a scale out cluster. There's scale up, there's scale out. We took a look at all those different kinds of clustering technologies and tried to figure out what are people really after when they want to choose to do one of those technologies or the other? What are you after when you look for a scale out solution? When you look for a scale out solution, you want a system that can grow and become bigger, but still has the same management endpoint. You want a system that you can grow and give people more capacity to without having to tell them to shut off their apps because you want to do a migration and move them to new hardware. Those are a couple of the key features that scale out gives, and we wanted to provide some of that functionality. Scale up clustering solutions are ones where you have a specific appliance and you simply add more capacity or more performance to it and make that individual device or appliance perform better or provide more capacity. What's valuable about scale out storage clustering is that it allows you to grow the environment while not changing the way your users are using it, right? You're not giving them a different API endpoint every time you flip from one storage appliance to another. And storage administration teams have to continue to have that flexibility and be able to do that sort of thing on the back end.
I have a question.
Sure.
So among the biggest challenges, there is the fact that you have an infrastructure that probably is already in place and you have to manage, traditional operation alongside, API driven or DevOps driven or whatever it's operation. So is this something that is focused just on one of the two? So just on a developer asking for provisioning a volume, or is there in place any mechanism to just give a full visibility to both of the teams at the same time about the resource consumed, some sort of multi-tenancy involved, some sort of, fencing, I don't know even how to call it from.
Yeah, those are all good questions. So I'm gonna actually walk you through some of the major features that we're offering. So a form of tenancy is in there, a form of visibility for both the consumer and the provider. And I'll sort of explain that separation. Another big part of what Fusion is providing is this very clear separation in the types of people who are accessing and managing storage. So I think I'll get to those questions as we go through here. So what Pure Fusion is doing, is essentially it's providing self-service storage. It provides some autonomous storage management functions. I'll go through what those are. It's really built to deliver storage as code. I feel super comfortable saying it delivers limitless scale. Obviously, in the real world, nothing can be limitless, and you're either going to run out of rack space or you're going to run out of rooms in your data center to put stuff. But Fusion itself is being built to operate at very high scale, very, very large numbers of storage objects, very, very large numbers of storage arrays, all getting managed from one combined sort of management paradigm behind Fusion. So traditional storage scale-out clusters are always going to have some sort of a limit. How many nodes can you add to a single cluster? How high can you scale any individual appliance in the cluster? We're kind of blowing past those limits with Fusion by obfuscating the individual arrays behind a construct that we call an availability zone, very much like in the public cloud. The whole purpose of Fusion is to allow storage administration teams to provide a self-service provisioning storage experience to their end users, to get storage teams out of the business of having to make volumes manually for people or having to make file systems manually for people and sort of dole those out of like a help desk ticketing system sort of method. Another thing it does is help you choose where to place workloads in the environment. We use some AI and ML-driven workload placement algorithms that we have in what we call the Pure One Cloud. So that's kind of what Fusion is really about at a very high level.
Sorry, I don't understand. So you're keeping mentioning scale out. does it work only for FlashBlade, or is scale out in the sense that it's very scalable kind of?
So when I mention scale out, I'm referring to the fact that you can continue to grow the backend storage system, adding more performance to the environment or adding more capacity to the environment, while from the user's perspective, it just appears to be the same storage system, but there's more capacity and more performance there. So it doesn't matter if it's our initial version that's releasing this year supports block. We'll add file support and object support later.
Abstraction and scalability.
Yeah,
not scale out.
Logical scale out rather than architecture.
Yeah, logical scale. Yeah. So what we're doing is we're not relying directly on the backend system having a traditional notion of scale out. And actually, when you get into seeing how the product works, we're going to show you one of the specific features that delivers some of the functionality that scale out does. Okay. So what Fusion's doing at a high level, a few things I'll touch on lightly here. You'll hear more detail about these later, is how you expose the environment in a consumable self-service sort of way. So for one thing, when you expose resources in the environment to consumers, you no longer will give a consumer access to one particular storage system or storage appliance. Instead, a consumer is given access to an availability zone that you get to define and create in a region that you get to define and own and create. So consumers are not specifically addressing individual storage appliances when they say, I need a volume to store my data or I need a file system to store my data. Instead, they interact with these constructs called availability zones. Additionally, as a provider in this environment, one of the things we're doing with Fusion is really trying to change the way storage teams should think about managing environment. We don't really think of storage administrators anymore, storage managers anymore. Instead, we want to think of storage providers. There's a person who is providing the storage service to users in the environment, and that provider needs to onboard users into the environment in a certain way. And the way that happens is that providers create these objects that we call a tenant. And a tenant is where the consumer will live and do all of their work. And tenants can further subdivide the environment into what we call tenant spaces. So this gives us a sense of management multi-tenancy in that the storage provider no longer has to give the end user access directly to the backend appliance. Instead, they get access only to the Fusion management layer. And through that consumer is bound to work only within the tenant space they have access to. So individual users will be scoped into these tenancy objects. And if you're working in a particular tenant space and your user or your access is scoped only to that tenant space, then you can only see and use the volumes that you have provisioned. And there may be someone else sharing the environment, using the environment in a different tenant space. And for example, when you list all the storage devices that you have, you see yours, but you don't see theirs. And then the way these storage providers allow the users that I keep referring to as consumers to get access to storage is by publishing what we call storage classes. So the user says, I would like a volume from a particular storage class. You as a provider get to provision and create these storage classes the way you want. You can give them whatever names you want, like the kind of ubiquitous common gold, silver, bronze that everyone uses, or you can say like ultra or massive or performance or something like that. You create these storage classes, and these represent sort of objects in the environment that the consumers can provision volumes out of. And if you provision a volume out of a particular storage class, it's going to inherit certain properties that the provider has defined. Those properties will be things like a capacity limitation, an IOPS per second limit, a bandwidth limit, how many of these things, how much performance you can get out of the storage environment. And then when it comes to implementing data protection, the consumers simply get to select from a library of protection policies that the providers define and assign those to the storage objects as they provision them. So you can say, like, I want to have an hourly snapshot of a volume, and a consumer simply gets to apply that there.
So obviously multi-tenant, you're going to have an issue with the noisy neighbor. So especially since this is all going to be in the cloud, I could see a situation where it's running slow is reported and it's going to be difficult to figure out exactly why it's running slow.
Yep.
So I presume you're going to talk about that more, but obviously that's something that has to be mitigated, right?
Yep. That's one of the, so the issue of one tenant being particularly noisy or hogging performance or causing performance problems on the back end is something we're specifically addressing in Fusion. Yeah, so let me talk about that. So some of the things Fusion's doing that I would more necessarily call back-end stuff. So like I mentioned earlier, Fusion isn't only about providing a cloud-like management and user experience. It's also about providing some very discrete features on the back end that will let storage teams act as providers and really run their environment from a service provider sort of perspective. One of those things that we do, starting on the left here, is we take the job of picking what array to put workloads on off the plate of any human being. So you may have a number of arrays that you've defined and configured into an availability zone. When a consumer says, I need a volume from AZ number 1, the Fusion management system will consult with our Pure One cloud, where we have some AI-driven workload monitoring that's going on. And based on the characteristics of the workload that's being requested, that system will automatically choose which array in the AZ to put that workload on. So there's no human intervention involved in picking where workloads initially land in the environment. So if you're not super familiar with Pure, there's a bit of Pure specific stuff here on the bottom. So X is our flagship block-based flash arrays. We call Flash Array X. So the first example you see there on the left is a workload being placed on Flash Array X number 1. That happens automatically. Another thing that the storage administration team or the providers don't need to get involved in is changing the class of storage. So in some cases, a consumer might choose to provision volumes in a Fusion environment that you defined as maybe high-speed storage class or performance-based storage class. And maybe you're a service provider using Fusion and you're charging them a certain amount of money for that storage class. They might change their mind and say, well, that storage was a bit too expensive, or my project slowed down and I don't need that much performance or capacity. Meanwhile, you're offering a different storage class in the environment that is actually serviced by a different kind of hardware on the back end, sitting in the same AZ. They don't need to ask you to move data around. A consumer, in some cases, can say, I simply want to change the storage class of these volumes I've already provisioned, and I want to change that from this one type of storage class that was high performance and maybe higher cost to this other storage class you're offering that is lower performance and lower cost. And on the back end, Fusion is using some technologies that we have in our flash array that allow us to non-disruptively move workloads from one physical appliance to another physical appliance. We can even do this in the cloud with our cloud block store arrays, which is an instantiation of the same kind of technology, but runs in AWS and Azure. So workloads could potentially be moved from busy or expensive cloud block store arrays to less busy or less expensive cloud block store.
Larry, there's a limitation to the ability to do that, I think, because if you look at the front-end presentation of LUNs that are coming out of your system, clearly they could be fiber channel. You're presenting a fiber channel LUN out. You could use Alua to rebalance that as you move it across between multiple arrays, but you need to keep the worldwide name consistent. Are you doing fiber channel based presentation of LUNs out of Fusion at the moment? Or
yeah, we're not doing fiber channel yet. The first instantiation this year is Ethernet and iSCSI. Okay. And we're also, to be clear, I'm not referring to these migrations happening from a physical availability zone that you might have on-prem in a private cloud to the cloud and back. So what we're talking about is...
You're talking about local replication in a metro cluster environment where you're migrating with active cluster, I guess.
Yeah, so this kind of goes to the noisy neighbor question that was asked earlier, which is in the third use case you can see here called utilize new resources. So one of the things you can do with Fusion is when you scale out your availability zone, say you've got 20 arrays in an AZ and you add a 21st array, you can simply add that array in there, plumb it into the network and make it part of the AZ. And then you can simply let Fusion start to place new workloads on that new array as they get requested. Or you can take a look from a provider's perspective, take a look at the entire AZ and see how things are performing and say, well, this array is a little busier than that other array. I would like to move some of the tenant spaces or some of the tenant users from array number 7 over to array number 14, or maybe to array number 21, the one I just added that's empty. I don't think I've said the word rebalance yet, but you'll probably hear that word a lot in the upcoming presentation. So we call that a rebalance. You don't see a button anywhere in the UI that says rebalance, but when we say rebalance, we mean that the provider has chosen to move a workload from one appliance to the other in order to sort of help smooth out the workload across the availability zone.
So it sounds like you're taking, a fleet of Pure Storage, and you're taking that fleet concept and you're turning it into a cloud of Pure Storage. I think it's a great idea because there's really been no way to group these things on-prem and organize all this stuff. That's fantastic. The question is though, how does a client know where to go? I mean, if it's IP addressed, is there a piece on the client that you're putting to help direct and tell the client, okay, here's where your storage is? I mean, do you install something on the servers that are consuming storage?
I think what the next slide is. I don't think that's on there.
It's a good question. If it's the next slide.
Yeah, it might be the next one. In fact, I can answer it on the next slide. I'll do that. One more thing I want to talk about here, though, before we take that question, is what we call rebalancing the fleet. And I will say that, rebalancing the entire fleet is something you could do with Fusion this year, because you can choose to look at the environment, see what systems are busy, redistribute and move active workloads around while users remain connected. You can choose to do that fleet-wide, but what we really mean with rebalancing the entire fleet is in the future we're expecting to offer much more automatic ability to do rebalances. So this is things like having the Pure One Cloud continuously monitoring the fleet of systems, both the on-prem physical ones in your private cloud and the Pure Storage Cloud Block Store deployments that you might have in AWS or Azure, and giving you recommendations to say, maybe you should redistribute your workloads. You'll get better utilization if you move this workload from one place to another. Maybe you'll get better dedupe, you'll get better performance. You might reduce costs, that sort of thing. And then even giving you the option to just let the system automatically do those moves for you is something we're thinking about adding later. So you can certainly do rebalance out of the gate in the early product. There's a bit of you sort of driving it though.
So you do this transparently to the host, and you check all the connections before doing everything. So you have the concept of the layout of the network. So if everything goes wrong somewhere, you can, you know that you can't move that line.
Right. Yep. Yeah, we don't just blindly go ahead and move the workload on the back end. We can tell that the host is accessing, using. We can, I think Anthony will talk a bit more in detail about the rebalance later, so I don't want to steal too much thunder there, but we can tell if the host is accessing the original location. We can tell when the host has started to access the new location. We don't shut off the old location until we're sure the host is healthy and accessing the storage in the new location. So I think this might be the last slide I have before we move on to some of the kind of more deep dive sort of things. So one of the things we wanted to offer with Fusion is, so Fusion's not simply, it's not just about traditional on-prem enterprise storage management. It's also not just about traditional applications. And it's also not only for new stack applications like Kubernetes or containers. So Fusion is not meant to live only in one space or the other. You could, as an enterprise, you could implement a self-service storage consumption environment in a traditional storage environment by obfuscating your application owners and users away from the storage and give them access to manage their own self-service storage environments through this control plane. So it's not just about on-prem private clouds, it's about using Cloud Block Store as the back-end storage systems in AWS and Azure. Like I said, for our initial version that we're shipping this year, we've got support for block systems on Flash Array. We're going to add support in the future for file and object coming from Flash Blade. We've got support for Cloud Block Store coming up. So what Fusion's really about is pushing the infrastructure back behind the storage administration team, letting the storage administration team operate as a storage provider, where they get to worry more about their front-end user experience and provide self-service experience to the consumers. And then giving them tools on the back end to be able to adjust where workloads are going and lifecycle the system without having to disrupt consumer or user access.